Okay, good morning, class. So at this point we're looking at functions. So we are told the function is a relationship between two variables. Okay. This is we're looking at the explanation on page. What page is this on? 139. We're reading from the explanation with examples on page 139. So let me know if the page number changes, okay? So you're looking at chapter 7 now. So we are told that the relationship between two variables. Where else did we see that? The relationship between two variables. We did straight line graphs, not so? So straight line is also a function. And you will see now today what is functions and so on. Okay. So the relationship between two variables x and y or any other letter can be expressed in several ways, using mapping diagrams, listing a set of ordered pairs, and using a table of values. I remember when we drew straight lines, there was two methods you could have used, or three actually. The two that we really looked at was the table method and the dual intercept method, not so? So they confirm here that there are three ways, mapping as well. We didn't do mapping yet, you'll see example of that now. So we express the relationship between these variables using mapping. So if we're looking at mapping, we would have what we have, the input value, which is normally our x, and we'll have our output value, which is normally our y. So our set of numbers here, we have our numbers there as well. So your input is -2, which is your x, -1, 0, 1, and 2. Can you see that? Now that's mapped onto or corresponds with, 2 corresponds with 4, -1 corresponds with 1, 0 corresponds with 0, 1 corresponds with 1, 2 corresponds with. You guys understand? This is just another way of representing the relationship between two values. Okay. Oops, I made a mistake there. What's my mistake? The 4 doesn't get written out all the time. So the output values were 4 was 4, 1, 0. You see there's a 1 and I already wrote 1. There was a 4 and I already wrote 4. So -2 corresponds with 4, -1 corresponds with 1, 0 corresponds with 0, 1 corresponds with 1 again, and 2 corresponds again with 4. Okay. We don't rewrite the number again and again, okay, as I did. I just thought it's different numbers, but okay. Listing in ordered pairs, there's your ordered pair already, and using a table of values, there's your table of values. No? We know how to do that already. A function, so write this definition down. A function is a special relationship between the input values and the output values, where every input value has only one output value. Note that the different input values can have the same output value. That is the definition of a function. Okay, I'll pause the video at this point. Thereafter, you write a definition for the domain and the range as well. Alright, so we are told that a function is a special relationship between the input values and the output values, where every input value has only one output value. Note that the different input values can have the same output value. Okay, so that's a function. You now also to write down the domain as well. The domain, the definition of the domain is The domain is a set of all the input values of a function. It's called the domain of a function. The input values are also what? The x values. Not so. So the x values are considered as your domain. The range is a set of all the output values. And what are the output values? The y values. So the set of all the output values of the function is called the range of a function. Of the function. We're still reading on page 139. You have said list the domain and the range of the function. So what's my domain? We know that the domain is all the possible x values, not so? So when we list, we normally write a squiggly bracket, okay? So what are the x values here? -2, -1, 0, 1, and 2. Not so? So what's my range of this one? The range is 4, 1, and 0. I'm not going to write 1 again, I'm not going to write 4. You all okay with that? At this point you should be able to do, on the next page on 134, on 40 sorry, you will be able to list the range and the domain of each of the following functions. Okay, so your homework is exercise 7.1. Now I'm reading on page, just check which page is this on, functional notation. Functional notation is on page 141. Okay. Give you a minute to write this down. Functional notation, page 141, we are told that the symbol f of x describes the elements of the range of the function for each element of the domain. You write that down. Okay? Just write that down for me and then do the explanation. Okay. So again, the symbol f of x describes the element of the range of the function for each element of the domain. So if you're looking at f of x equals x squared plus 1. Let me see that. This is an equation of a parabola. We will be drawing this parabola this graph very soon. Normally when you draw the line y is equal to mx plus c, what type of, this is actually the line graph, I meant to have said, the graph y is equal to mx plus c is a straight line graph. Not so, we dealt with this last year. So what they did was they took this f of x and this y and they replaced it with f of x. So f of x is equal to mx plus c, is the same thing as we had before. However, this is just represented as in functional notation method. Can you see that, people? So this f of x here to us is equivalent to a y. Are you all okay with that? So for f of x equal to x squared plus 1, that means that wherever I see an x, if you've got f of minus 1, the input is minus 1. Let's see what's the output. So wherever we see an x, we put a negative 1, so it's negative 1 squared plus 1. What's negative 1 squared? 1 plus 1 is 2. So that means to say that if x is equal to minus 1, we've got a y value of 2. If I must write that as an ordered pair, this would be negative 1 and 2. You guys understand? That's a coordinate. What if we had f of 3? What would that be? If that is your equation, it will be 3 squared plus 1. What's 3 squared plus 1 is 10. If I must write that as an ordered pair, what would it be? 3 and 10. And so on and so on. You will understand? Alright. So let's read what they say. For x, f of x equal to x squared plus 1, f of minus 1 is equal to 2 means that x is equal to minus 1. The corresponding element of the range is 2. My domain is negative 1, my range is 2. Okay? We write f of minus 1 equals 2. We say that f at negative 1 is 2, or the function value of f at negative 1 is 2. We call f of minus 1 equals 2, the image of minus 1. Okay? The image is like the point tool. Okay. Now we're looking at the example on page 141. We are given that f of x is equal to x squared plus 1. Determine the value of f of minus 1. That's the one we just did now, not so? Isn't it? Why did I ask you to do it again? Okay. Let's look at the next one. So now example 2. On page 141, we are given f of x equal to 2x minus 3. Determine the value of f of 3 in the first case. Should I do that for me quickly? Okay, so if you're looking at A, f of x equal to 2x minus 3, so f of 3 is going to be 2 into 2 minus 3. That's all. So x is now, 3. X is now 3. Sorry man. Are you confused now? Why is it 2? Okay. Good here now for once. 2 times 3 is 6. 6 minus 3? 3. All okay with that? Try B quickly. So that would simply be 2 times negative 3 minus 3, which is negative 9. You all agree with that? Your input value of minus 3, while you got the output value of input value of negative 3 correspond to the output value of negative 9. Or in ordered pair, it will be negative 3 and negative 9. Not so? Right. C, f of negative 3 over 2. But if I see x, I put a negative 3 over 2. So it's 2 times Negative 3 over 2 minus 3. You all agree with that? Which is negative 3 minus 3, which is negative 6. You all agree with that? What if this question was determine the value for x if f of x is equal to 15? Determine the value for x is if f of x is equal to 15. So what are we going to do here? What are we going to do here? We know that this was not asked, no? If f of x is equal to 15, what is f of x? So y, yes. But f of x is also equal to 2x minus 15. Not so. So f of x, which is 2x minus 15, sorry, minus 3 is equal to 15. So 2x minus 3 is equal to 15. So what do I do from here? Solve for x. They get over 15 plus 3? Huh? 18. 18 divided by 2? 9. You guys understand? How do you get 19? You guys are a little crazy, no? Any confusion there? Are you all okay?
Yes, sir.
Right. There's the next one. Given that f of x, given that g of x. Now they could have said f of x equals mx plus c, or they can say g of x is equal to mx plus c, or they can say p of x, m of x, t of x, s of x of x, whatever. They can put whatever they want to do. Okay. But often we use f of x, g of x, and h of x. Now and then k of x. Okay. But as I said, they could have used any. Okay. Given that g of x is equal to 1 minus 2x, evaluate. Evaluate, determine, calculate all means simplify means all the same thing to us. And so. So if g of x is equal to 1 minus 2x, what is 2 times 2 g of x? 2 times g of x. Try that one quickly. Alright, so people, what is g of x? 1 minus 2x. So this will simply be 2 times 1 minus 2x, which is 2 minus 4. You guys get that? Nice. Okay, let's look at b. G of 2x. What are you going to do here? Wherever we see an x, we put it. Wherever we see an x, we replace it with 2x. Can you see it? Remember, g of x is 1 minus 2x. But now, here's a 2x here. Can you see that? So here's must go away, 2x. You see the difference? So this would simply be 1 minus 2 times 2x. Not so. So it's 1 minus 4. Okay. Let's look at C. C says g of x plus 2. What do you think is going to happen here? 1 minus 2x, yes? Plus 2. Why? Because g of x is 1 minus 2x. Make sense, people? So it's going to be minus 2x plus 3 or 3 minus 2x. D, g of x plus 2. Wherever we see an x, we put a x plus 2. Can you see that? That would simply be 1 minus 2 times x plus 2. Get rid of the bracket, so it's 1 minus 2x minus 4 minus 2x minus 3 or minus 3 minus 2x. You guys understand? Any confusion there? For homework, I would like you guys to do exercise 7.2. Exercise 7.2, and this is on page 142. So the first part of tomorrow's lesson, I'm going to, before I answer the questions, please remind me. I must first do the second example on functional notation. Okay. People enjoy the rest of your day. Good morning, class. How did the test go today? Huh? If you had watched the videos, it was easy. Why? Because each and every one of those questions was in the video. Yes.